Addiction has been described as a global humanitarian crisis. It affects millions of people around the world, has been the subject of numerous media depictions, and is potentially one of the most stigmatized conditions that there is. But what happens neurologically when we actually become addicted to something? Scientists first began to seriously study addictive behaviors back in the 1930s. Before this, it was widely assumed that people with addictions were in some way morally flawed or lacking the willpower and mental strength to overcome their problems. It's a story we've all come across. The diligent student starts skipping school and letting their grades slip. A trustworthy, honest friend might get caught stealing. The immaculate beauty queen stops caring about their appearance. These out-of-character behavioral changes can be directly linked to changes within the brain itself. In this video, we're going to delve deep into the science behind addiction. But first, let's talk exactly about what is an addiction. According to the NHS, addiction can be defined as not having control over doing, taking, or using something in a way where it could be harmful to you. This is most commonly associated with drug abuse, but the definition can be extended to include just about anything. Gambling, sex, or even work can lead to harmful, destructive addictions, with the affected people causing themselves, as well as the people around them, harm by neglecting all other aspects of their lives. Innovative brain imaging techniques have revolutionized our understanding of what is happening to the brains of affected people. We can now see that addiction actually changes the brain's structure in ways that can alter the way it works and process information. To understand the ways that this might impact their choices and behavior, we need to start thinking about rewards. Deep in the brain sits the reward pathway, a neuronal pathway that connects clusters of neurons from different areas of the brain in a highly organized way. Also known as the mesolimbic pathway, the reward pathway's primary function is to reinforce sets of behaviors. If we think back in evolutionary time, it was helpful to have a mechanism that rewards us for behaviors useful for survival. Things like finding food in times of famine or escaping from a source of danger. It's even more helpful to have a way to remember how we managed to stay alive, so that we can repeat it the next time we're in a similar situation. The reward pathway achieves all this primarily through the use of a particular neurotransmitter called dopamine. Following an appropriate action, a small burst of dopamine is released by the reward pathway. This causes you to feel a small jolt of satisfaction, which acts as a reward for keeping yourself alive, encouraging you to repeat the same behavior in the future. Dopamine signals also act on areas of the brain involved in memory and movement, which help us build up memories of what is good for survival and makes it easier to do it again. Dopamine is also released when good things happen to us. Rewarding experiences such as winning a game or getting a compliment at work send signals to release bursts of dopamine. More indirectly, if you take a painkiller like an opioid or have an alcoholic drink, certain neurons within your central nervous system are suppressed. The resulting feelings of peace or relaxation also come about through a spike in dopamine release. This, unfortunately, paves the way for both drug and non-drug addictions. Whenever an action or a substance is abused, such as excessive gambling or overconsumption of pornography, junk food, or drugs, the reward system floods the entire circuit with levels of dopamine up to 10 times higher than a natural reward. Depending on the route of administration, this can happen almost instantaneously, with the effects lasting much longer than a natural stimulus. The overstimulation of the brain's natural reward mechanism produces intensely euphoric and pleasurable sensations that act to strongly motivate people to seek out more of it. Unfortunately, if we keep on taking and engaging in these behaviors and flooding our reward systems, over time the brain attempts to adapt to these chronically elevated levels of dopamine. The brain actually reduces the number of receptors that are able to respond to dopamine signals, with special channels being inserted to remove dopamine from the circuit. It also means that dopamine release is reduced as well. With your ability to feel pleasure now drastically reduced, you experience tolerance, a state where you need to experience more and more of this substance or action in order to release the same amount of dopamine. This explains the predominant seeking behaviors commonly seen in long-term addiction. Eventually, areas outside of the reward pathways are affected too. Brain regions involved in decision-making, judgment, and even memory begin to physically change, with some areas having neurons added and some areas dying away. The overall effect is to make drug-seeking behavior become driven by habit rather than conscious thought, almost like a reflex. In effect, that person's brain has become hijacked, concentrated on the sole purpose of seeking out more and more of the addictive substance, whatever the cost. Not everyone who tries a drug will become an addict. So why do some people develop strong addictions while others don't? We can split the answer into three main reasons: genetics, environment, and development. You've probably come across someone describing themselves as having an addictive personality. In fact, recent research suggests that up to 75% of the likelihood of developing addiction comes from your genetics. These biological differences can make a person more or less vulnerable to addiction and can influence the strength of any withdrawal symptoms experienced if they attempt to quit. Addiction is quite clearly a complex trait and is most likely influenced by multiple different genes. No one is born destined to develop an addiction. So what else is at work here? The next point is the social environment, and that plays a significant role in rewiring of your reward system. For example, if you've got a stable relationship or doing great at work, you're going to feel pretty good. It's thought that people who don't have much stimulation of their reward pathways through social environment or interactions are more likely to seek out addictive activities as a way to stimulate their own neglected reward pathways. One study found that monkeys lower down on the social hierarchy who didn't receive as many social benefits, such as grooming, were much more likely to self-administer cocaine in a laboratory than monkeys higher up in the social ladder. Now comes the last point: development. We know that addiction can happen at any age, but we also know that the earlier in life someone tries drugs, the more likely it is that they will develop an addiction. The brain doesn't finish developing until your mid-20s. In particular, an area that continues to mature during adolescence is the prefrontal cortex, the part of the brain responsible for reasoning, keeping your emotions under control, and making decisions. We all know how rebellious teenagers are, wanting to go out at odd hours, try new things, fight back against what they perceive to be parental or social tyranny as they try to find themselves. Unfortunately, this means that the adolescent brain is hardwired for taking risks and making poor decisions. This extends to things like trying drugs or continuing to take them, which is why intervention in this group is especially important to prevent lifelong problems. No one chooses how their brain is going to react, and there is no single factor that determines whether a person will become addicted or not. Nonetheless, it's a real problem that millions of people face every day. These videos are made possible by our Patreon supporters. You can support us by using the link below, and don't forget to drop us a like if you enjoyed this video. See you next time.